Hi everybody, today we will see again 4 questions from the mathematical side, mathematical methods part. We have this first question: consider the transformation to a new set of coordinates theta and eta from rectangular Cartesian coordinates xy. Okay, from x and y we are transforming into theta and eta, where this theta is given by 2x plus 3y and eta is 3x minus 2y. So here what we have to find is the area element in the new coordinate system theta, eta. The area element dx dy is, okay, the area element has to be found out in the new coordinate system. So here we are using the idea of Jacobian. Suppose we have two functions u and v, which are two independent functions of two independent variables x and y. Okay, u and v are the functions of two independent variables x and y. Then dou u comma v, actually functions uv by dou x comma y. This is actually called the Jacobian. This is defined as dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y. So this is actually a determinant. Okay, that determinant is the Jacobian of uv. Okay, Jacobian of uv with respect to xy. Okay, so this is the Jacobian Jacobian of uv with respect to xy. We might be asked to determine the Jacobian directly for three functions u, v, w, where u and u, v, w are functions of x, y, z. This is the Jacobian. This is straightforward: dou u by dou x, dou u by dou y, dou v by dou z, like this. So here dx dy, the area element in the new coordinate system, that is given by dou xy, dou theta, eta. This is the Jacobian. This is the magnitude or modulus of this Jacobian, d theta, d eta. So this is the definition, the transformation. The area element in the new coordinate system is given by this. Okay. So without going into the details, we are directly using this equation. So it is easy to find this Jacobian dou theta, eta, dou xy. Although we need dou xy, dou theta, eta, actually it is from the given equation it is easy to find this dou theta, eta, dou xy. That is dou theta, dou x, dou theta, dou y, dou eta, dou x, dou x, dou y. So we take the partial derivative of theta with respect to x, that will be 2, with respect to y, that will be 3. With respect to x of eta, that will be 3, with respect to y, that will be minus 2. So we will be getting this determinant 2, 3, 3 minus 2, and that its value is minus 13. So dou xy, dou theta, eta, which will be inverse of this, okay, that is equal to minus 1 by 30. Now using this equation, dx dy is the magnitude or modulus of this d theta, d eta. So I have this equation as 1 by 13 d theta, d eta. So this is the answer. A similar question is here. A rectangular area is formed by two vectors x and y as shown in figure 1. Okay, this is x and y. A new set of vectors representing the area A2 is as shown in figure 2 and given as u1 is x. u1 is x itself, but u2 is kx plus y. Okay, where k is a dimensionless constant. Okay. So what we have to find is the Jacobian of the frame u1, u2 with respect to xy. Okay, the question is we have to find the Jacobian of the frame u1, u2 with respect to xy. As we saw in the previous problem, Jacobian of u1 u2 with respect to xy is this: dou u1 u2 dou xy, that is dou u1 dou x, dou u1 dou y, dou u2 dou x, dou u2 dou y, the determinant. So as we find dou u1 dou x, we will get 1, dou u1 dou y 0, dou u2 dou x k, dou u2 dou y 1. So that is given here, and its value is 1. So this is the Jacobian. So this is the answer. So next let's move to this third question. Suppose that f of x is given by this, a polynomial, 3x raised to 6 minus 2x square minus 8. Then which of the following statements are true? That is the question. The sum of the various options are given. Sum of all of its roots is 0. The product of its roots is minus 8 by 3. Sum of all its roots is 2 by 3. The complex roots are conjugates of each other. So we have to select the statements which are true from these 4 options. Here we need not find the roots. It is not easy to find the roots here, but we know if you have a general equation, ax raised to 6, bx raised to 5, cx raised to 4, dx cube, ex square plus fx plus g equal to 0. If such a standard equation is there, or such a general equation is there, then the sum of the roots is given by minus b by a, the coefficient of the term corresponding to x raised to 5, b, this is a, the first term, x raised to 6. So sum of roots is given by minus b by a, similar to the quadratic equation b by minus b by a. The product of the roots is given by g by a. Okay, g is the coefficient of the term x to the power 0. So g by a gives the product of the roots. Okay, in quadratic equation also it will be c by a. C is the term which has the power x, which has the coefficient, or which is the coefficient of x raised to 0. So product of roots is here given by g by a. So if I write this equation, okay, here I have f of x equal to this. I am writing this as 3x raised to 6 minus 2x square minus 8 equal to 0 to find roots. Okay, f of x equal to 0. It can be written in this format: x raised to 6 minus 2 by 3x square minus 8 by 3 equal to 0. And I am converting this equation into this format. So I have x raised to 6, x raised to 5 is not present here, so 0x raised to 5, 0x raised to 4, 0x cube minus 2 by 3x square, 0x, x is not present here, 0x minus 8 by 3 equal to 0. So as I compare, the sum of the roots is given by minus b by a, which is 0, here it is 0, 0 by 1, that is equal to 0. Product of roots is given by g by a, that is minus 8 by 3 by 1 minus 8 by 3. So sum of roots is 0, product of roots is minus 8 by 3. So answers are A, this is correct, B is also correct, D is also correct, because complex roots of any equation, any polynomial are conjugates of each other. Okay, complex roots are always conjugates of each other. So here A, B, D are correct. These statements are correct. Now let's see a function f of x equal to minus x, where x, when x is between minus pi to 0, x when x is in between 0 and pi. So this is expanded as Fourier series. The formula is this: a0 plus sigma n equal to 1 to infinity an cos nx plus bn sin nx. Now the question is, which of the following is true? a0 not equal to 0, bn 0, a0 not equal to 0, bn not equal to 0. Okay, such options are given here. So here we have to expand this as a Fourier series. Fourier series expansion is this: if f of x is equal to a0 plus sigma n equal to 1 to infinity a n cos n x plus b n sin n x, then a0 is given by this 1 by 2 pi minus pi 2 pi f of x dx. A n is 1 by pi minus pi 2 pi f of x cos n x dx. b n is 1 by pi 1 by pi minus pi 2 pi this pi is not there, minus pi to pi minus pi 2 pi f of x sin n x dx. So this is bn. But if f of x is given by a0 by 2, in some cases it might be given as a0 by 2 and sigma n equal to 1 to infinity this, then a0 will be 1 by pi minus pi 2 pi f of x dx. Okay, then a n and b n are same. So it might be given like this or like this. Okay, and a n and b n are same in both the cases, but a0 will be different. Here it will be 1 by 2 pi this, and here it is 1 by pi this. Okay, the difference comes from this. Here a0 is simply a0, here we have a0 by 2. If we represent this f of x given to us, f of x given to us is this minus x when this x is between minus pi 0, it is x when x is in between 0 pi. So f of x is this, and we can see this is correct, this is actually an even function. Okay, so clear to us, this is an even function. Okay, when x is positive and x is negative, f of x is same, so it is an even function. So when we calculate a0, since f of x is an even function here, this will be simply this will not be 0, we can evaluate it. This will be 2 times 1 by 2 pi 0 to pi f of x dx, because f of x is an even function. But when it comes to bn, since f of x is an even function and sin n x is an odd function, this integrand, this part f of x sin n x, that will be an odd function. So if it is an odd function, this will be equal to 0. If we evaluate it, this will be equal to 0. So we are not evaluating a0 bn from the idea that f of x is an even function. We can know, or we know a0 is not equal to 0 since this is even, but since this is odd, this will be equal to 0. F of x sin n x is odd, this will be equal to 0. So a0 is not equal to 0, bn is equal to 0. So the correct option is A. Okay, a0 not equal to 0, bn equal to 0.